Welcome to TSAT. Today I am going to discuss a topic in geography regarding atmospheric pressure and winds. So, in this context, we need to know what is meant by atmospheric pressure. Atmospheric pressure is the weight of the column of air at any given place and time is known as atmospheric pressure. So, here as we know that we are under an ocean of air above us. So, the air itself is made up of certain mass of certain gases, because every mass is being subjected to gravitational force, because mass is being attracted by the gravitational force. This force exerts certain pressure on the earth's surface. So, this pressure being exerted by the weight of the air is atmospheric pressure. So, this atmospheric pressure is being measured with an instrument known as barometer. So, here in this context, in the projection being given to you is a traditional basic fundamental atmospheric pressure measuring instrument known as this barometer, which is being described as a mercury barometer. So, in this instrument which we are able to see this on the screen is a kind of tumbler containing mercury, and you are taking a pipe of a meter long pipe completely filled with mercury, which is closed at one end and open at the other end. The opened end pipe filled with mercury is being inverted into this container containing mercury. So, at sea level, at normal atmospheric pressure, when this meter long tube is being marked with millimeters, what happens is the rise of mercury in this column is been observed to 76 centimeters or 760 mm. So, why the mercury in the column is rising above the level of mercury in the tumbler? The basic reason behind it is because of the weight of the air or the atmosphere over the mercury in the tumbler is pressurizing the mercury to rise to the column. So, this is because of atmospheric pressure. So, here in this context, as we have heard about regarding the variation of atmospheric pressure because of different factors, the height of this column of mercury in this transparent pipe, the glass tube, is not the same. With the change in the atmospheric pressure because of n different reasons, as we have discussed in the previous episodes, that with the increasing in the temperature, what happens is the atmospheric pressure decreases. So, when the atmospheric pressure decreases, what happens is the level of the mercury falls down. When the pressure increases, what happens is when the temperature decreases, the pressure increases, because the molecules of air, when they are cold, the vibration or the activity or the oscillation of the air particles is less, so that the air particles condense, leading to increasing in the density of air. The more the density of air, because of coldness, the weight of the air is more, consequently the atmospheric pressure is more. So, when the temperature decreases, the pressure increases and the column rises. Apart from these factors, altitudinal factor also plays a major role in terms of the variation of atmospheric pressure. For example, when we are climbing a mountain, what happens is the column of air above us gradually decreases. So, here in this context, for example, in the projection being given to you, this is a column of air above us. So, with the increasing in the altitude, what is happening is the amount of air when we climb a mountain, what happens is the column of air above us decreases. So, obviously the mass of air decreases, obviously the pressure decreases. Apart from these factors, the other factor which is responsible for decrease of atmospheric pressure with increasing in the altitude is, as been projected to you, the density of air decreases with the increasing in the altitude. The less the density, less the weight. Apart from decreasing in the column of air with the increasing in the altitude, the density of air also decreases. So, when you are at this altitude, the amount of air above you is less. So the mass is less, the pressure is less. When you are at the surface of the earth, the amount of air above you being subjected to gravity is more, the mass is more, the gravity is more. So these are the factors. The factor specifically initially which I have mentioned is one is the temperature which impacts the atmospheric pressure. The second factor is the density. The third factor is the altitude. Altitude is the reason for decreasing in pressure. The rate at which the pressure decreases is 1 millibar per altitude of 10 meters. That is how the amount of atmospheric pressure decreases with the increasing in the altitude. So when there is a weight felt over this mercury, the mercury in the column rises. When the pressure decreases, the weight decreases and the column falls. So in this case, apart from this, horizontally when we compare, relate, the pressure is not the same throughout the surface of the earth when we relatively compare horizontally. The reason behind it is, as we know that the temperature which is being distributed across the latitudes is not the same. The reasons are, which is leading to differential heating, means when the surface of the earth is being heated because of 10 different factors in a different ways. A region is heavily heated, a region is not heated effectively. So in this context, what happens is, because of the angle of incidence of solar radiation, which is more at the equatorial regions and less decreases towards the poles, what happens is the number of calories of heat being received at the higher latitudes is less. So the temperature is less, but at the equatorial regions, tropics and equatorial, more or less we receive perpendicular incidence of solar radiation, where the amount of calories of energy per square meter is more, so the temperature is more, so the pressure is less. So one fundamental fact to understand climatology, one thing we need to understand is, always air flows from high pressure to low pressure. If we are able to understand this phenomena, the whole climatology can be understood, because the way the air being circulated is being classified into primary circulation, secondary circulation and tertiary circulation. Primary circulation means the phenomena of atmospheric circulation happening in a homogeneous manner over a global phenomena. When this same kind of phenomena happening throughout the globe is a primary circulation. Secondary circulation is a kind of pattern of circulation which is confined to a continent or more than a continent, which is not happening like primary circulation throughout the globe or the earth. Whereas the tertiary circulation is the local impact, where the regional impact lead to the variation of flow of wind only in that particular region. So based upon the extent of the way the winds behave, they are being classified into primary, secondary and tertiary circulation. Whether it is a primary circulation or a tertiary circulation or a secondary circulation, the reason behind it is a pressure gradient. The pressure gradient. Pressure gradient means the difference between the high and the low pressure. The high pressure and low pressure are being created because of the specific factors which I have mentioned in the initial part of the discussion, because of temperature factors and density factors. Higher the density, more is the pressure. Higher the temperature, low is the pressure. Lower the temperature, high is the pressure. So these factors, so depending upon these conditions of pressure gradient, always wind blows from high pressure to low pressure place. So apart from this, this is known as the horizontal movement of air, whereas in the case of current is considered, current is the vertical movement of air. So the vertical movement of air happens when the density of air decreases. So when the density of air decreases, what happens is the air surrounding, which is denser because of cooler, rushes to the low pressure point. So the air which is having a less density rises above vertically. This vertical movement of air is known as current. So now you are able to differentiate between what is wind, what is current. what is meant by pressure gradient in the atmosphere, and why wind blows from high pressure to low pressure. So, based upon these factors, there is a pattern of a regular pattern of movement of winds throughout the globe across the latitudes. So, because there is a regular pattern based upon these gradient of pressures being developed across different latitudes, these pattern of wind which is regular is being given names. So, one such is known as these trade winds. So, the trade winds, the northern trade and the southern trade. So, in these northern trades, for example, here which is being projected to you, the tropical easterlies, in the north, tropical easterlies in the south are also being described as trade winds. Trade means this is nothing related to trade. Trade is a word in Germany which implies that there is a consistent steady flow of wind. That is what trade is. It is a German word. So, because they are continuously flowing with a steady flow and they meet at the geographical equator, or they follow 𝗳𝗃𝗺 rather than mentioning it as a geographical equator, it is apt to mention the word as 𝗳𝗃𝗺, known as intertropical convergence zone. So, intertropical convergence zone is a region where the northern trades, means the easterlies in the northern hemisphere and the easterlies in the southern hemisphere, meet at a point known as intertropical convergence zone. So, here this intertropical convergence zone, when the trades are moving, they are in the form of wind. After meeting, what happens is these winds will be converted into currents which move vertically. So, these trades, the northern and the southern trades meet at the intertropical convergence zone, which is in a short form been written as 𝗳𝗃𝗺, rises above. So, the reason for the rise of this 𝗳𝗃𝗺 is you have got two reasons for this. One is the way the kinetic energy the trades have got. The second factor, or the primary factor, this must be considered as the primary factor. The amount of heat available at intertropical convergence zone is maximum because of the angle of incidence of solar radiation. So, because of this reason, air molecules get activated or the water vapor gets activated because of the solar energy which can work against gravity. So, in this process of rising against gravity at 𝗳𝗃𝗺, because the energy is being used against gravity, at a point of time when the energy is completed, what happens is they stop rising above. The rise of air or the current at 𝗳𝗃𝗺 extends till 𝗃𝗃𝗺 at the equatorial region, because by the time the air rises to equator, the energy in the air is completed. So, it starts diverting to either sides, to the north and south pole directions. So, it leads to the formation of a cell as been mentioned here, leading to a kind of cell on the either side of the equator known as Hadley cell. So, because of this kind of pressure, it leads to the development of wind and current. Is a classic example here, where this kind of cellular form of wind circulation happens from the equator to the polar regions. So, here in this case, what happens is, because of this reason, there will be when you are able to understand the three-dimensional way of circulation, you will be able to understand perfectly the way the air is being circulated in the troposphere. So, the first layer of the atmosphere, which is being described as troposphere, this is how the air circulates. So, here what happens is, we have got a different pressure belt here. So, subtropical high pressure zone we have got here. So, the high pressure zone is because of the subsidence of air. When the air is being subsiding, piling upon one another, the density increases and the pressure increases. That is the reason why it leads to a high pressure zone. So, 𝗳𝗃𝗔 is a low pressure zone because it is rising above and the temperature is high. So, intertropical convergence zone always follows thermal equator. Thermal equator is a line joining points on the surface of the earth which is receiving the maximum amount of solar energy, means the maximum amount of temperature we have got. So, thermal equator is a line joining points which receives the maximum amount of solar energy, and at this point we have got the highest temperature. So, intertropical convergence zone always follows this thermal equator. This thermal equator oscillates to north and south of geographical equator because of a phenomena known as apparent migration of the sun. So, because of the tilt of the axis of the earth to the plane of the orbit of the earth. So, when the axis of the earth is being tilted to the plane of the earth's orbit, the axis of the earth is not maintaining a 90 degrees angle. It is being tilted to 23.5 degrees. So, with a tilt of 23.5 degrees angle, and when it is revolving around the sun, what happens is the incidence of solar radiation, the perpendicular incidence is not always concentrating on the equator. The perpendicular incidence of solar radiation happens from to the north to the extent of Tropic of Cancer as been projected to you, for example. So, when in this condition the 𝗳𝗃𝗔 will be at the equator, geographical equator, but because of the apparent migration of the sun, because of the tilted axis and the revolution of the earth, the perpendicular incidence in the summer solstice in the northern hemisphere migrates to Tropic of Cancer. So, the opposite happens in the case of winter in the northern hemisphere. The perpendicular incidence of solar radiation goes to Tropic of Capricorn. So, because of this reason, the 𝗳𝗃𝗔 will not be always on the equator. The 𝗳𝗃𝗔, depending upon the seasons, will be oscillating to north and south of geographical equator because of the isolation of thermal equator, because of apparent migration of the sun. So, this Hadley cell, Ferrel cell and polar cells which I have projected to you are not always incoherent with the latitudes. They will be oscillating to north and south as per the thermal equator oscillates to north and south of the equator. So, based upon this difference in the heating and differential heating, pressure gradient is being created, and it leads to the development of this kind of unique pattern of circulation of winds. This pattern of circulation is being described as primary circulation. So, because of the high pressure being developed at these latitudes here, the wind from this high pressure belt deviates to the equatorial regions on one side and towards the subpolar low pressure belts on the other side. So, here this leads to the formation of a Ferrel cell. So, and after forming the Ferrel cell at the 60 degrees latitude, the wind from the westerlies and the polar easterlies meet here at 60 degrees latitudes and rise above, and the one which is traveling towards the pole descend at the poles, forming a polar high pressure region. So, this leads to a formation of a certain pattern of air circulation. So, these winds, the primary circulation winds, have been given certain names. So, these are known as trade winds. The opposite one at the tropopause are known as anti-trades. The westerlies, anti-westerlies, the polar easterlies and the anti-polar easterlies. So, this is how we are able to imagine this in a three-dimensional manner. This is how the primary circulation happens throughout the globe in either of the hemispheres. It happens both in the northern hemisphere and the southern hemisphere. So, horizontal distribution of pressure. The equatorial low pressure belt is also known as the doldrums. So, this equatorial low pressure belt has got a secondary name. This is how a question can be asked. what is meant by doldrums? There might be a question. So the equatorial low pressure belt can also be described as doldrums because of extreme calm air. So there is a current there, you don't have winds. Because of this reason, you don't experience wind. So it is calm. So only currents are found here. So here next you have got horse latitudes. So horse latitudes in the subtropical high. So in these horse latitudes, what you have got here is these are extending from these 45 degrees latitudes where these are known as horse latitudes traditionally because in this region, especially in the southern hemisphere, when the winds are calm, what happens is because of high pressure, what happens is because of the weight of the vessel, the traders used to push the horses into the ocean so that the weight of the vessel can be decreased because the horses can swim to an extent. So that is the reason why these latitudes are being described as horse latitudes. Next is the subpolar low pressure belt. This is the subpolar low pressure belt because of which the wind rises above, and the polar high, the wind descends here. So these are the different kinds of belts and the directional flow of wind. In winter, the continents are cooler than the oceans and tend to develop high pressure centers, whereas in summer they are relatively warmer and develop low pressure belts. So because of this reason, what happens is these kind of conditions with the variation of seasons, the directional flow of wind varies, because as I have already mentioned, always wind blows from high pressure to low pressure. High pressure is being created by low temperature, low pressure is created by high temperature. So for example, in the statement number 1, in winter the continents are cooler, means the pressure will be high, and the ocean than the oceans, and tend to develop a high pressure. So in this way, whereas in the summer they are relatively warmer and develop low pressure. So because of this reason, winds blows from ocean to continents. Winds and currents, which we have discussed the difference between winds and currents. So the reason behind this is unequal heating of the earth's surface is one of the main reason for the pressure differences. So throughout the surface of the earth, they are not equally heated because the angle of incidence of solar radiation is varying from equator to the poles is one of the factors. All the topographical features or all the geographical features will not have the same reflecting capacity of the solar radiation, which is being described as albedo. The oceans reflect in a different manner, the ice caps reflect in a different manner, the deserts reflect in a different manner, the forests reflect the sunrise in a different manner, where in the presence of clouds, in the absence of clouds. If you have more continuous clouds, cirrostratus, they reflect the cloud more, or when there is more cloud in the morning, what happens is they will not allow the solar radiation to enter into the atmosphere. If the cloud is being formed in the evening, they will not allow the terrestrial radiation to escape into the space. So there are many different multiple factors which are responsible for differential heating of a region, responsible for developing pressure gradient, so leading to the development of wind. Direction and speed of wind are controlled by the combination of factors. So what are the different factors which are responsible for impacting the direction and speed of wind? One is the pressure gradient force, as we have discussed. Always wind blows from high pressure to low pressure. Gravity, because of gravitational force, what happens? The density increases. The more the density, the more the pressure. Next is the Coriolis force. Coriolis force is a force which will not allow the wind to flow to the pressure gradient. Because of the earth's rotation, the wind, when it is flowing from high pressure to low pressure, is being deflected to its right in the northern hemisphere. So in this process, what happens is, because the earth is a rotating body in the space, what happens is, because of this rotation, the air flowing will be deflected, and this deflection is known as Coriolis force, or known as Coriolis effect. So the Coriolis effect, because of the rotation of the earth, changes the direction of wind flow. The centripetal acceleration, So what is happening is centripetal and centrifugal forces. Because there is a gravity pulling towards the center of the earth, and there is centrifugal force because of the earth's rotation which moves away from the earth. So because of the centripetal force means a force acting towards the center of a body is centripetal force, because of gravity impacts the direction of force. And the frictional force, because of the different topographical features, you have got mountains, forests, plains, deserts, oceans, offer different levels of friction to the flowing air, impacts the directional flow of wind. So these are all different factors which impacts the directional flow of wind. So this is what a Coriolis force is. Due to the rotation of the earth, winds do not cross the isobars at right angle at the pressure gradient. So isobars are lines joining points having the same atmospheric pressure. So the forces directs but get deflected from their original path. This is called the Coriolis force. So or it is also known as Coriolis effect. So questions can be developed in this way. What are the factors which are responsible for Coriolis force? The rotation of the earth is the major factor for the development of Coriolis force, or simply they may ask you what is meant by Coriolis force. So we have got periodic winds. Periodic winds means seasonally winds oscillate in an opposite direction. For example, we have got monsoons. In the case of India, monsoons can be described as periodic winds because we have got summer monsoons and winter monsoons. In the summer monsoons, wind blows from southwest of India, whereas in the winter monsoons, wind blows from the northeast of our country. So for example, here in the case of the monsoons are considered, what happens is, see this, when the 𝗳𝗃 migrates north, what happens is the southern trades cross the geographical equator. When they are being subjected to the Coriolis force, they turn into monsoons. And when the sun migrates to the southern hemisphere, what happens is the intertropical convergence zone migrates to south, that is the blue line. In this process, the 𝗳𝗃 shift to the south and the southern trades shift to the southern hemisphere. In this process, what happens is the northeastern monsoon setbacks. So here, when you are able to see in this projection, the rise of 𝗳𝗃 is maximum at India and Chinese part. The reason behind it is the low pressure generated here is more because the proportionate land mass here, as we know that land gets heated more and develops more amount of low pressure. Because of this reason, the 𝗳𝗃 is shifted more to the north in the northern hemisphere, which is responsible for the manifestation of monsoons more prominently in this region than any other part of the world. Is a classic example of secondary circulation. So here in this case, for example, in the southwest monsoon season, this is the directional flow of wind. In the northeast monsoon season, this is the directional flow of wind. The primary cause for this is shift in 𝗳𝗃 to the northern hemisphere, and the secondary causes are the development of low pressure because of the dominance of land mass, and the Tibetan plateau develops a low pressure in summer. So these are the different factors which are responsible for the development of monsoons. So friends, we shall meet in another episode discussing the topics essential of the continuation. So friends, we shall discuss the other topics in the next episode. Thank you.